Hello everybody, we continue with the main biomass conversion techniques. In a previous video, the mechanical and biochemical methods were discussed. In this section, we will go through the thermochemical processes. Thermochemical methods include mainly combustion, gasification, and pyrolysis. Combustion, or sometimes called incineration, direct firing, burning, it is a high-temperature chemical reaction between a fuel, in our case biomass, and an oxygen, atmospheric oxygen in air. Combustion represents perhaps the oldest utilization of biomass, when cooking and warming were the first needs. Today, the scale of combustion plant ranges from very small heating homes up to large-scale industrial plants in the range 100 to 3000 megawatt. Co-combustion of biomass and coal is an especially attractive option because of the high conversion efficiency of these plants. Chemically, combustion is a complete oxidation of fuel. Biomass mainly consists of carbon, oxygen, and hydrogen. So here we can see two main chemical reactions: oxidation of carbon and oxidation of hydrogen, with carbon dioxide and water production. These reactions are exothermic, meaning that heat during combustion is released. Combustion of biomass produces hot gases at temperatures around 800 and 1000 degrees. It is possible to burn any type of biomass, but in practice, combustion is feasible only for biomass with moisture content less than 50%. So, combustion is mainly used to convert the chemical energy stored in biomass into heat and electricity using various items of process equipment, such as stoves, furniture, boilers, steam turbines, and turbogenerators. Pyrolysis is also a thermochemical process of biomass decomposition. But unlike combustion, pyrolysis takes place in the total absence of oxygen. There are different techniques for this process: slow pyrolysis, meaning low heating rate, and fast pyrolysis, meaning high heating rate. From technical point of view, pyrolysis is less developed compared to direct combustion and gasification. From a chemical perspective, pyrolysis is a decomposition of biomass by heat, without any oxygen in the system. There are three main products during pyrolysis: solid, charcoal; liquid, bio-oil; and gaseous fraction, a mixture of different gases such as carbon monoxide, carbon dioxide, methane, and hydrogen. Typical temperatures for pyrolysis are between 250 degrees and 600. Pyrolysis is the first step in combustion and gasification process. So, pyrolysis can be used for producing different fuels and chemicals, such as bio-oil and charcoal. All these products can be also used for heat and electricity production. And finally, gasification. Gasification is the most interesting process that converts solid fuels, in our case biomass, into gas, which then used as fuel, gas, or chemical feedstock. Gasification technologies are commercially available, but there are some challenges to overcome to make the technology fully commercialized. Again, from a chemical perspective, gasification is partial oxidation of biomass at high temperatures. The product gas is a mixture of gases such as carbon monoxide, carbon dioxide, hydrogen, methane, and nitrogen, if air was used for gasification. The mixture can be burned directly or used as fuel for gas engines and gas turbines. The product gas can be also used as feedstock in production of chemicals, for example, methanol and ethanol. Syngas, or synthetic gas, is a mixture of hydrogen and carbon monoxide. Syngas provides the feedstock for many chemical reactions, including methanol synthesis and Fischer-Tropsch liquids. One of major applications of syngas is the production of liquid transport fuel. Today, a large amount of liquid fuel is produced using Fischer-Tropsch synthesis from the syngas generated from gasification of coal. The same liquid fuel may be produced from biomass-derived syngas. Gasification is a thermochemical process producing heat, electricity, and a mixture of gases, syngas, that allows the production of different chemicals and transportation fuels. One promising concept is the biomass integrated gasification combined cycle, IGCC, where gas turbines convert the gaseous fuel into electricity with a higher overall conversion efficiency. Please see an example 1.1 in Basu book. In my opinion, it is a very good example where you can see the differences in efficiency when biomass is combusted and gasified. So, different products can be produced from biomass through several processes and methods. The choice of a method is dictated by biomass properties and desired use. We can conclude that not all methods are suitable for all types of biomass. High moisture content biomass is better suited for biological conversion processes, while low moisture content biomass is better for thermochemical processes. Biomass is unique compared to solar and wind energy harvesting, and the only process that can produce chemicals, fuels in addition to electricity and heat. The gasification technique is one of the most promising technologies. So once again, more information can be found in the books. Thank you very much for your attention.